Section 2.2, histograms. While a frequency distribution is a useful tool for summarizing data and investigating the distribution of data, an even better tool is a histogram, which is a graph that is easier to interpret than a table of numbers. A histogram consists of bars of equal width drawn adjacent to one another unless there are gaps in the data. The horizontal scale represents the classes of the quantitative data values, and the vertical scale represents frequencies or possibly relative frequencies. Important uses of a histogram: visually displays the shape of the distribution of the data, and we started to talk about this in the last section about whether something was normally distributed, and we'll be able to see that better with a histogram. It shows the location of the center of the data and the spread of the data, and also helps us to identify our outliers and gaps in the data. The relative frequency histogram has the same shape and horizontal scale as a histogram, but the vertical scale is marked with relative frequencies instead of the actual frequencies. So here we see the frequencies here and the frequencies shown here. If we had a relative frequency, we would have the relative frequencies along the y-axis. Explore the data by analyzing the histogram to see what can be learned about CVDOT, the center of the data, the variation, the shape of the distribution, whether there are outliers, and then if there's any time parameter that we might be able to look at. So here's some common distribution shapes. We see in the top left, bell-shaped, comes up, drops off. So starts low, comes up, drops off, just what we talked about in the last section. Uniform, the heights of the bars are all about the same. Here's the skewed distribution. It has a longer tail on the right side on this one, and here's a skewed distribution to the left, which has a longer tail on the left side. Because this histogram is roughly bell-shaped, we say that the data have a normal distribution. Frequencies start low, work up to a maximum, drop back down, and if we drew a line in the middle and put the two sides on top of one another, it's roughly symmetric. Skewness, a data set is skewed if it's not symmetric and extends more to one side than the other. Data skewed to the right, positively skewed, has a longer right tail. Data skewed to the left, negatively skewed, has a longer left tail. And we can also assess normality with what's called a normal probability or normal quantile plot. Criteria for assessing normality with a normal quantile plot. In a normal distribution, the pattern of the points in a normal quantile plot is reasonably close to a straight line, and the points do not show some systematic pattern that is not a straight line pattern. Not a normal distribution, the population distribution is not normal if it has either or both of these two conditions. The points do not lie reasonably close to a straight line pattern, and the points show some systematic pattern that is not a straight line pattern. So here's an example of a normal distribution. And this is a QQ plot, normal probability plot, normal quantile plot. And we see that if we were to draw a straight line through the points, there's points on above and below the line, and there's no systematic pattern other than just a randomness around that line. Here's one that's not a normal distribution. We see a whole lot of points clustered down here. This is actually a skewed distribution. And then we see points tailing off up here. So it's not reasonably close to a straight line. This one is not a normal distribution. It follows a straight line, but you notice the pattern. There's a bunch of points above the line, and then there's a bunch of points below the line. Be sure to watch the StatCrunch video for this section, and here's a link to that video, and the links are also located in the Unit 2 module in my courses.